All right, hey, morning, folks. Just want to go ahead and get started with the notes from section 5-6 here today, and hopefully things will kind of work out okay. So let's take a look at these here. So starting with something that we've learned from the past, okay? Let's see if we can kind of analyze this picture here and see what we know to be true. So let me get that kind of in there. Much better. Okay. So if you take a look at the two triangles that I have presently down here in your notes, what do we know about these two triangles? Well, I hope that you're thinking that the triangles are congruent by side, angle, side, if we look at that. Okay. So as a result, I'm just going to write this down. Go ahead and jot this down as well. Triangle ABC would be congruent to, matching up the corresponding triangle. I'm going to do triangle DEF by side, angle, side. Okay? Now, because of that, we've talked in the past that all the other corresponding parts have to be congruent by CP, Now, I'm not going to list all the other parts, but I'm going to focus in on this right here, the fact that AC would be congruent to DF. Okay? So this is the focus for today's, at least the first half of the lesson here today, the fact that those segments would have to be congruent. Okay? Now, let's quickly transition over to another pair of triangles. What do we know to be true? Well, what we have right now is we don't have congruent triangles because this angle here is not congruent to this angle here. So how does that play out within this problem here? Well, let's do this. I'm going to put down that angle B is, not D, angle B is greater than, right, your greater than symbol, angle E. Okay? So as a result of that, therefore, we have talked in the past about how the angles and the sides opposite those angles have an influence on each other within triangles. Okay? So for example, last week we talked about if we have two congruent angles within a triangle, the sides opposite those angles have to be congruent. That was part of the converse of the isosceles triangle theorem. Okay? So again, if this angle is congruent to this one, then that side there has to be equal to this side here. Okay? So with that being said, no longer are these two angles congruent, okay? Which would make this segment not congruent to this one. But what can we say about this segment with respect to this one? Well, I hope that seeing that this angle here is bigger than this angle here, that would then mean that this side here has to be bigger than this side here. So our conclusion from this is going to be that AC is greater than DF. Okay? That segment there has to be bigger than the other one. All right? So that leads us to a little paragraph here, the side angle side inequality theorem. I like that one better than the hinge theorem. The hinge theorem, I understand a hinge as a door opens up, right? As it opens up, as the hinge opens here, right? Opens, the side opposite has to become larger, okay? So in taking a look at this paragraph, it says this: if two sides of a triangle are congruent to two sides of another triangle, then in the included angle, okay, so I might do this, the included angle, it's got to be the one between those two sides, of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle, okay? You may have to read that a couple more times to fully grasp what's going on there, but this is an example of that, okay? Now, as I think about that, let's actually flip over to the back side here and take a look at an example similar to that, okay? So number one is just like this. So we've got two triangles here, and if I mark the reflexive property, the fact that XZ is shared between those two segments right there, we know that the triangles aren't congruent because we don't have congruent angles right here. But what we do know is that since this angle is larger than this angle, then this side here would have to be longer than that side there. So I might do something like this: the fact that XY, that segment, is greater than XW, okay? And you could put by the hinge theorem, or the side angle side inequality theorem. Okay, so that would be an example there. So pretty basic concepts. If I take a look at this one right here, I realize that 15 is equal to 15. That's good. 12 is equal to 12. That's good. Oh, but these angles that are included aren't congruent, so we don't have side angle side. But since 72 is bigger than 61, that then means that JK is longer than MQ. Okay? And so I can go ahead and, again, hinge theorem or side angle side inequality theorem. Okay? All right, now let's go back to the front side here and take a look at the next example. So it says, what do you know to be true within these two triangles? Well, I have the three sides of this triangle congruent to the three sides of this triangle. So as a result, I'm going to go ahead and say that triangle ABC is congruent to triangle DEF by side, side, side. Okay? Now, as a result of that, again, all the other angles the corresponding angles have to be congruent. I'm going to specifically look at two here. I'm going to say angle B is congruent to angle E by CPCTC. Again, corresponding parts of congruent triangles are congruent. Okay? Now, take that to the next one here. We have these two sides congruent to these two sides. This side's longer than this side, so what can I conclude to be true? Well, if this side is longer than this side, then the angle opposite here would have to be greater than the angle opposite there. So I'm going to say this, that angle B is greater than angle E. Okay? And so, and maybe I should have started like this. Actually, I'm going to erase that just a quick second here. Seeing what I did on the previous one. Let's actually write down that AC being greater than DF then leads us to the fact that angle B must be greater than angle E. Okay, so hopefully that makes sense there based off what we're given. Now, that leads us to the theorem here, if I can get the right page. Okay, so the theorem says this, back up just a bit. You guys can see it on your paper there, but I may highlight some things here. Okay, again, it's like a paragraph. If two sides of a triangle are congruent to the two sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle, so meaning the angle that's between the two congruent sides that we are referencing within the triangle, measure of the first triangle is greater than the included angle, again, the angle that's between the two congruent sides that are being referenced, measure in the second triangle. Okay? So let's watch this play out within some of these examples here. So in this first one, again, I'm going to mark the reflexive property. FC is congruent to FC. We notice that BC is bigger than FD. So as a result, I'm going to go ahead and say the angle opposite, so the angle, or you could say the included angle here, the angle that's between those two congruent sides, must be greater than the angle between these two congruent sides. Okay? So I'm going to put down that angle F, or angle BFC, is greater than angle DCF. Okay? And again, you can either use what's called the side, side, side inequality theorem. And again, what are we referencing here within the three triangles? The three sides. Two of them are congruent, the third ones aren't. How does that play out within the figure? Or you could go ahead and say the converse of the hinge theorem. Okay, so again, I don't care which one you want to use. Like I said, I prefer the side inequality theorem. Okay, so in this one, very much the same way. Okay, these two sides are congruent. This side's congruent to itself. However, this side here is bigger than this side here. I might mark it like this too. Okay, so what does that mean? Well, the included angle over here, the one between the two congruent sides, must be greater than the included angle over here. Okay, so I'll put down that angle, let's see here, angle VRT is greater than angle SRT. And like I said, I like the side inequality theorem. Okay. All right, now there is another type of problem that we should look at, and that's this one down here. Okay. Determine the range. Okay, so range meaning that we're not looking for an exact answer, but there's a range of possible answers that we could have for A. Okay. Now, here's what I'm thinking. I know that these two sides are congruent to each other, and I also know that this side here is congruent to itself. So I've got two sides from the two different triangles congruent, and then this side right here is smaller than this side right here, okay? And so I know that the angle opposite, this one, is going to have to be smaller than that one, okay? That's one way to set it up. So you could do 9a plus 15 is smaller than or less than 141, okay? Now, you can set up the other way. 141 is greater than 9a plus 15. You get the same outcome, okay? So let's actually go ahead and solve this here. If I subtract 15, I get 126. And if I divide through by 9, let me make that A. 9 goes into 12 once with 3 left over. 9 goes into 36 4 times. So A has to be smaller than 14, okay, in order for this to make sense. So for example, if I was to plug in a 13 right there, 9 times 13 is 117, I believe. Clear that. Let's try that. 9 times 13 plus 15. Okay, so we got 132. If you notice here, if I plug in 13 into this possible, in this right here, it meets that requirement. It has to be smaller than that. Okay. If I plug in a 14, let's try 14 here. I know it's kind of glare. There we go. 9 times 14 plus 15. Ooh, I got 141, but we know, according to what we know about the triangles here, that this angle has to be smaller than this one, okay? And so as I look at this, I know what A has to be smaller than, but do I know what A has to be bigger than? Because, for example, if I go ahead and put down that 9 times negative 15 plus 15, well, that gives me a negative 120 degree angle. That's not even possible, okay? So how do I figure out what A has to be greater than? I got to figure out the lower bound. I've already got the upper bound. This is the most it can be, but what's the least it can be? Well, if you think about it, in order for this angle to exist, okay, this angle is going to have to be greater than 0. So to finish this off, if I do 9a plus 15 must be greater than 0, okay? If I subtract 15 from both sides, I get that right there. And if you divide through by 9, I get a negative, what would that be, 1 2/3. Okay? And so the range of possibilities here for A must lie between 14 and negative 1 2/3. okay? And so as I look back at this, okay, let's try this for just a second. A number that would lie between these two, let's say -1. So if I plug this in, 9 times -1 plus 15, well, that gives me a 6-degree angle, okay? I don't know what the measure of this angle is. It's probably not 6 degrees, but in order for it to exist, it would have to be greater than -1 2/3. So yeah, that meets that requirement there, okay? So again, am I saying I know what the measure of this angle is? No, not this time. But since I know this angle has to be smaller than this one, I do have a range of possible solutions for A, okay? So hopefully that makes sense there, folks. I want you to go ahead and take a look at the practice problems that I have given you in Schoology, and we'll come back tomorrow and see how you did. So, hey, have a great day. We'll talk to you later. Bye.